transformations. So you guys should have, okay? So your warm-up looks like this, right? So we have the parent function, and your parent function is basically where, okay, you can think of it as it's like the most basic type of graph for that function, okay? This is where we start. This is where, you know, all the other versions come from, all right? So this line, right, with a positive slope, okay, it has, you know, it goes through the origin. It goes through 0, 0, yeah? If you look at the next one, it says f of x plus 1. What happened to that? What happened to that graph? It went up 1. Okay. So if I added a plus 1 at the end, it went up 1. Okay. What about the next one? F of x plus 2. Now, there's a plus 2 inside the parentheses with the x. How did that, what did that do to that graph?
Went up 2.
Did it go up 2? Okay, so it looks like...
It also went up 2.
You also went to the left 2? Alright. No, I don't like this line. Okay. Alright. And then look at your next one. Negative f of x.
It flipped it.
Yeah, it flipped it, right? Alright. You know what? Let's look at this b. I don't like this line. Let's go to the b. Your parent function for this one. This is actually an absolute value parent function, okay? So its vertex is at 0, 0 right now, yes? Okay, what happened in the next one? F of x minus 2.
It went down 2.
Yeah, it went down 2. That vertex went down 2, right? Okay, because there was a minus 2 on the outside. All right. How about the next one? F of x minus 1.
It went to the right one, the vertex.
Yeah. You see what happened to the vertex? The vertex went to the right 1. That x minus 1 was inside the parentheses with the x, and then it went right 1. What about this negative f of x? What happened?
Flipped.
Yeah, it went from a b to a, I don't know, what is that?
TP.
Oh, a TP.
It was the first thing I thought of, okay?
Good. The next one you can't tell as much, but f of negative x, it actually flipped it on the y-axis, which doesn't really matter because it's still a b anyway, right? Okay. Right? Okay. And then the 2 times f of x, what happened to that b?
It became smaller.
Yeah, it like stretched it, right? So it became narrower. Good. Okay. So let's look at our notes then. When we talk about transformations, we're talking about how we shift graphs, how we move graphs, okay? Like the kind of things that you, I don't know, what you would do with graphs. So if I have a graph, f of x, and I did plus k, added a number on the outside, what does it do? If it's a positive k, it moves it up k. And if it's minus k, then it moves it down k. Alright, now after we do this, we'll go to lunch, okay? So we'll come back and we'll pick up. Okay, so before lunch we said f of x plus k. If there's a plus a number on the outside, it moves it up. If it's minus k, it moves it down, the graph, right? Oh, it's right here. Sorry. Put this down here then. Okay. Yeah, right? I didn't even realize. Okay. Well, that's nice. They separated it for us. All right, so then the next part. F of x minus h. So, you have minus a number inside the parentheses with the x, right? That means that the graph is going to shift right h. And you always have to tell us how many, okay? Don't just say left, right, up, down. So if x minus h is going right, then x plus h is going how?
Left.
Left. Good. Left h. So left and right is inside the parentheses with the x, and it's the opposite, right? X minus h is to the right. Okay. So then this one, negative f of x. So you have a negative on the outside, right? This one flips, and it's actually, it reflects, okay? It reflects across the x-axis. That means that it flips down, okay? Not side to side, down. Yeah? And the side to side, we actually don't do that here. We do it in honors. So. All right. The next one, we have a times f of x, okay? And you know, both of these are a times f of x, so you have a number in the front. But if your number, if the absolute value of a is greater than 1, okay? So it'll be like 2, right? 3, 5/3. Then that means that it is going to stretch, right? And we'll just leave it at that. Say it stretches, okay? All right, so the next line, it says if the absolute value of a is between 0 and 1, so give me a number that's between 0 and 1. 0.5, so 1/2, right? What else?
1/3.
Okay, yeah, 0.7 and 1/3, but the thing is with these, they're rarely going to give you a decimal. They'll probably use a fraction, okay? So when this happens, then it compresses, okay? It will compress. Right? So with the stretching and the compressing, let's write down something else so that we have an idea, okay? It's kind of like a little hint for us. Stretching means that it gets narrow. More narrow, narrower. Is narrower a word?
I don't think
Is that
so.
weird? That's weird, right? So maybe more narrow. Does that make sense? Narrow. Right? Okay, so then if you stretch the graph, it makes it get really narrow, right? But if you compress the graph, what do you think happens to it? It gets
thicker.
yeah, like wider, right? So we can write for that we can write wider, right? That's a word, isn't it? More wide sounds weird. Wider. Right? Okay. Questions about this? Okay, so let's practice. All right. It says, given the graph of f of x, sketch the graph of each transformation. Okay. This graph is f of x, and they give us f of x plus 1. We're looking at the things that are added on to our basic f of x. Okay? So if I have a plus 1 on the outside, how did this move?
Up.
Yeah, up 1. So I'll write that, up 1. Would anyone like color pencils? Yeah. Okay, so if it's up 1, what you're going to do with this graph is basically just find some nice pretty points and move everything up one. That's it. So this guy right here, move it up one, right there. And this point right down here, right? Move it up one. Yeah. This point here, move that up one. And then all the way down here at the end, move that one up. And we just connect the dots here. There we go. Up one. Questions? Okay. So let's look at the next one. Has f of x plus 1. Oh, there's a plus 1 in there. That's new, right? And then minus 2. That's another new addition, a transformation, right? So tell me what happened here. The minus 2 did what? Yeah, down 2. What about this plus 1 that's inside the parentheses with the x?
Left 1.
Good, left 1. So that's what you want to do. Go to each of those points again, down 2, and then left 1. So with this point, I'm going to go down 2, left 1. Right? Down 2, left 1. Down 2, left 1. Down 2, left 1. Okay? All right, so the next one. So when it reflects, like this one, and I know that it reflects because why? Yeah, because of this negative in the front, right? That tells me that it reflects across the x-axis. Okay, when you go to graph that, all right, this is the easiest way I found. So we're going to flip it across the x right here, right? So I'm going to go to my graph. So if I look at this point, it's right on the x, so you can't flip it, right? It's just there. Leave that one alone, okay? Let's go to this next point right there, okay? This one is how far from the x-axis? Yeah, 3 down, right? So if we want to reflect it or flip it, then we have to go 3 up. Okay, so since it went 3 down right here, I have to go 3 up. 1, 2, 3, right there. Yeah? And then the next one is this guy. I'm going to use a different color here. That one. Since it's up 3 right now, what do I need to do with it to flip it? Move it down 3. 1, 2, 3. Does that make sense? And then what about this last point? It is up 1, 2, 3. So in order to flip it, I need to go down 3. So here, 1, 2, 3. Yes? Okay. There we go. Don't forget to connect your dots, okay? All right, let's go on to the next one. Or the next 3. All right, so the 2 transformations here. I have a negative in the front, and I have a minus 2 inside the parentheses with the x. What happened?
Reflect and move to the right 2.
Okay, reflect, and then right 2. Okay, this is a little bit tricky. So this first one, we said since it's right on the X, it can't reflect, but it can go right too. So 1, 2. Right? This one right here. Reflects. So since it's down 3, I'm going to go 1, 2, 3, up 3, right 2. And then this one. So it's up 3, so I'm going to go down 1, 2, 3, and right 2. And then this last one is up 3, so I'm going to go down 1, 2, 3, and right 2. And there we go. Any questions on this? Okay, I want you guys to try the next one, please. And then we'll do 6 together. Okay, so this one, you got a negative in the front and a -1 and on the outside, right? So this reflects. And it also goes down 1. So this one reflects, it's down 1. Right there. This one reflects and then down 1. Yes? This one reflects, 1, 2, 3, and then down 1. And this one reflects, 1, 2, 3, and then down 1. Okay. All right, so number 6. Have a 2 in front of f of x, right? So having a number that is greater than 1, what happens? How does that change the graph?
It becomes narrower.
Yep, stretches and narrow. Okay, good. And were you going to explain what to do? Okay. Well, all right. So let's write that first. Let's write stretch. Okay. All right. And then what? What do you do? Yeah, you're doubling the y value. How far is it from the x? Okay. So you see this guy right here? It's right on the x-axis, right? So that's 0.
Mm-hmm.
What's 0 times anything?
0.
0, so leave that one alone. Okay? Look at this guy. How far is this point from the x?
3.
Yeah, it's 3 down, right? 1, 2, 3 down.
Mm-hmm.
Okay. But if it said multiply by 2, what's 3 times 2?
6.
Okay, so now we have to go 6 down. 1, 2, 3. Like you have to double it, right? If they give you a number, you know, fraction, a negative sign, you're basically just multiplying that to your y value because this is a point, right? Okay, so there's that one. How about, oh no, I get the highlighter. How about this one? Yeah, right now it's up 3. 3 times 2 is 6, so it needs to go up to 6. So just 3 more. There we go. Does that make sense? And then this one, up 3. You need to go 3 more. And there we go. Okay. Sorry, it's a little bit crooked. So then do you see it? It's stretched, right? Became more narrow. All right. Questions? Okay. All right, so this one. So this is really interesting because now they want you to come up with the equation. Okay? So it said, what is the equation of the solid line if the parent graph is the dotted? Okay, so we're going from the dotted to the solid. All right. So you know what I would do is just write down what happens. So from this dotted, right, this point corresponds with that, right? So from the dotted one, how did it go to become the solid line point? From the dotted to the solid.
Up to.
Up to. And it looks like they all did that, right? Okay, so then that's it. Did it stretch? Did it
No.
get wider? No. So this is g of x. So you would say g of x, how would you write up to?
Plus 2.
Plus 2. Does that make sense? Okay, so let's look at h of x. So starting from the dotted to the solid, right? Because this point goes at that point. How did it move? It went 1, 2, down to 1, 2, 3, 4. Down to left 4. Yeah? Okay. So left 4 tells me it needs to go inside the parentheses with the x, right? H of x, if it's left 4, is it plus or minus 4?
Plus.
Plus. You gotta think the opposite, because when you're thinking left, you're like, oh, it's minus 4, but it's the opposite, plus 4, okay? And guys, you have to memorize those transformation rules, all right? And then down 2 is what? Minus 2. There you go. Oh, so the next one is a little bit crazy. First off, what do you notice?
It's flipped.
It flipped, yeah, because it went from a V to a TP, right? So you know that it flipped. Okay, so we have reflex. And then let's see what else it did. So from this point to over here. Yes. 1, 2, 3. Left 3. And then up 2. Okay. You guys try this. Write the equation for j of x, please. Yes? Good. Good. Okay. If you have any questions about this, please raise your hand, okay? All right, so let's switch gears a little bit. Let's talk about something called point slope form, okay? So when we talk about lines, right? It's easier to talk about transformations when we write it in this form, not slope intercept, not the y equals mx plus b, okay? And point slope form, it has 2 different ways that you can write it. Okay, and they're going to be written out there for you. Here you go. Y equals, or y minus k equals. Okay? All right, so A. Those A's, that's the slope of the line. And HK, these guys, right? That is a point on the line. HK, it goes with your X Well, the point would be what? X comma y. Okay. So just remember that the X and the H go together and the Y and the K go together. Okay. All right. So here it says, what are the shifts of the following lines? This is a line, right? But we know, okay, A is right there. That's our slope, right? This -3 that's inside with the X, that's another shift. And this plus K out here, that's another shift. Yeah? All right. So tell me, what are the shifts here?
2, -3, and 4.
Yeah, tell me in words. What are the transformations? What does this +4 mean at the end? The plus K. Huh?
-4.
What? Up, down, left, right?
Four.
Yeah, up 4. What about this X -3? Left or right? Right. Right 3. And what about the 2? Yeah, it would be the stretch, right? But it's the slope. Okay, so stretches, and then here, can we just make a note? That's the slope. If you think about it, slope of 2, that's rise over run. Rise 2, right 1. Yeah, that would be a pretty stretched out graph. All right, how about number 2? You know, this one is a little bit weird because it's in the y + 2 form, right? And so just by looking at this, I wouldn't be able to say, oh, well, it goes up 2, okay? Because what I have to do is I need to subtract that 2. I got to make it equal to y. So then this becomes y equals negative x plus 1 minus 2. Okay?
Down 2.
Yeah. All right. So then this, this, and this. Okay, what happened? What are some of the transformations?
Down 2.
Down to, uh-huh. Thank you. Okay. All right. Any questions? Okay. All right. So the next part, you're going to write the equation of the line in point slope form. Okay, and they're going to give you information. So they said write the equation of the line containing the point 0, 3 with a slope of 1/2. Okay. So up at the top, whenever you get a problem like this, I would write down y minus y1 equals okay. I know that x1 and y1 are hk, right? But if I write it like this, it kind of helps me remember. Yeah, I gotta put the x and the y in. Okay. I'll tell you guys something. This y, the plain old y, and the plain old x, they stay x and y. Don't plug in numbers for those. Okay? That's just like part of your equation. And remember, a is the slope, right? Okay, what is your slope here?
1/2.
Okay, 1/2. And then they gave me a point 0, 3. Yeah? Okay. So my points, all right, 0, 3. When you guys go to plug it in for x1 and y1, you see how there's a negative in front of it? Yeah? So you have to remember, when you plug it into the equation, this is going to feel like the opposite. Okay? Because it has a negative in front. So when I go to plug this in, I would say y minus, what's the y number that they gave you?
3.
3. You see that? You see how you had a positive 3, but when I plugged it in, it became a minus 3? That's what I mean by the opposite. But you know that the standard is y minus and x minus. Does that make sense? Okay. Equals 1/2 x, minus 0,
Parentheses.
right? Can I say x? Yeah. If it's a 0, you don't have to put minus 0. Okay? All right. So you could write it like this, or if you wanted to move this 3 over, you could write it. You could write it like that as well. Okay? That's because I just added this guy over. All right? You can write it in either form. All right? It'll be fine. Just make sure you do it right. Questions? All right, try another one. Write the equation of the line containing the point 2, -5 that is parallel to this line.
Cross.
Okay. Wait, guys, what do you remember? Okay, think back to geometry, think back to algebra 1. Parallel means that they have the what? Same slope. Parallel means that they have the same slope. So if it's parallel to this line, what's my slope there?
-2.
Yeah. So slope equals -2. That's what I want to use, and I'm going to use these points here. Okay? So y, okay, minus, what's my y number that they gave me?
-5. So when they
-5. So wait, y minus a -5? What's minus minus?
plus.
Plus. Good. So I'm going to change that, and I'm going to say plus. Equals -2 x minus, what's the x number that they gave me?
2.
2. Okay, so there you go. You can be done here, or you could write it as y equals, and then just move that 5. Right? Questions? Okay. All right, what is the equation of the line containing the point 2, 2 that is perpendicular to that line? Okay, so perpendicular means that the slope opposite and what? Um, opposite reciprocal slope. Okay, it means if it was a positive, make it a negative, and then flip that number, right? So then your m, your slope, right, becomes what? If it was 2/3, now it's
3/2.
negative 3/2. 3/2. Good.
Wait, m equals slope, right?
Yes. You know what? I don't have to write it then. Just write it out. There we go. Okay. All right. So if I were to go write this equation, y minus, what's the y number that they gave me? 2 equals -3/2 x minus 2. My x number is also 2. Yeah. So you could write it this way, or you could write it this way. And if they ask you to list the transformations, I would write it this way, the y equals, okay? Or just change it to that so you could tell me the transformations. All right. Okay, so let's do some practice. Write the equation of the line, continue that point with a slope of 2/5, and try this one too. You guys try 1 and 2, please. Perfect. Okay, thank you to Elise and Hannah for doing numbers 1 and 2. Okay, ready for the next ones?
You skipped 3.
Did it skip?
It's under.
Oh, it's underneath? Oh no, it's not even there? All right, so technical issue. I didn't have number 3, but problem solved, right? Write the equation of the line that has the point -2, -3, and is perpendicular. Do you remember this? It's like a throwback to geometry, right?
Oh.
Perpendicular to y plus 2 equals 5 times x minus 4. So my slope here is what?
-1/5.
Good. If it's 5 there, then the reciprocal is 1/5 and then opposite. There we go. Yeah? So slope equals -1/5. These points. Can I do this one? I wanted to call somebody, but sorry. So y plus 3, because it would be a minus a negative, right? Equals -1/5 x minus a -2, so that's plus 2. Yes?
Mm-hmm.
So there you go. Or if you did it the other way and you just made it equal to y, then this would be y equals -1/5 x plus 2 minus 3. Okay? All right, so the next part, it says sketch the graph. Okay, so here is g of, here's f of x. G of x is how it changed, right?
Mm-hmm.
So if they ask you to sketch the change on the graph, what I would do is write down in words what happened, okay? So first, let's do that. What happened here? Okay, so if you had just plain old f of x, what are some new transformations that happened here?
You're moving to
Okay.
the right one.
Right one, and then
Up 3.
up 3. So remember what we did before about each of the points, on the graph? Let's move them. Right 1 and up 3. So this guy was this right 1, right 1, up 3. 1, 2, 3. Just on the highlighter. So then this one, right 1, up 3. This one right here, right? Another little corner, another little change. Right 1, up 3. And then this one is right 1 and up 3. And here we go. Done, right? Pretty good? Okay, you guys try the next one. This one can be a little bit tricky. You gotta do some crazy things here. Okay, so this one, it reflects, and it also goes up 3. Do you agree? Okay, so watch me. Make sure I don't mess up, because when I'm up here on the smart board, sometimes it's a little crazy. So what is this? Reflects, and then up 3. Reflects, and up 3. Reflects, to go up 2 and then up 3. Reflects, and then up 3. Yes? Okay, good. Sure, you didn't get this? Okay. All right, did everyone get this?
Mm-hmm.
Okay. All right, so state the transformations from f of x equals x. All right. So if I have this, remember what I said? If it's written in point slope form like this, you you need to change it to y equals before you can start telling me the transformations. Okay? So with this one, move this 3 over to the other side. Okay. Then you have y equals negative x minus 4. And then, you know what, you can combine these two together. They're both on the outside. No, let's plus 1 minus 3.
-2.
Yeah. Right? Okay. So now you can tell me the transformations. What happened? I see this one, and that one.
So there's a negative slope of 1.
So, okay, so what happens? What do you call that?
reflects.
It reflects. Okay, what else?
4.
Right? 4.
Down 2.
And then down 2. Great. Do we have another one? No, that's it?